Well, hello everyone, and welcome to the February 2025 edition of the St. Louis Java Users Group. For those who don't know, the St. Louis Java Users Group is an informal group. Our first meeting was in May of 1997, so we're approaching 28 years here for us. Attendance is free. There's no formal membership list. Normally, we meet on the second Thursday of each month, except December, when there is no meeting. There's just too many things going on over the holidays for us to organize a meeting in December. Now, we're meeting 1 week later to accommodate our speaker schedule here tonight. You can join us for food and social at 6 p.m. in the training room, and we try to start the meeting at about 6:30 p.m. The meeting room, and our normal meeting location, is in the Object Computing Incorporated training room, and that's at 12,140 Woodcrest Executive Drive, Suite 310, and of course that's St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Zach Klein, Ted Doyle, Robert Levitt, Wei-Chi Gao, and me, Bruce Alspo, there in the blue shirt at the end. You can reach all of us of the steering committee by sending us an email at that address that's at the bottom of your screen. That's javasigsc@googlegroups.com. The St. Louis Java Users Group would not be possible without the help of our sponsors. So if you know a potential sponsor, please have them email us at the steering committee at that address, javasigsc@googlegroups.com. So from left to right, Object Computing Incorporated is our original sponsor from 1997. They've been with us all these years and filled in so many times and basically saved the group more times than I can count, providing the training room tonight, as well as the pizza tonight. That's because of Object Computing that has sponsored that. So a big thank you to Object Computing. At the end of this meeting, we will be raffling 2 Manning ebooks and of your choice, and we will also be raffling this time, believe it or not, 4 JetBrains licenses. So maybe you have a pretty good chance of winning here tonight. Now, I should say, though, if you're watching the recording, I'm sorry, you're too late. You must be present to win, either in person or online. So stick around after the meeting, and we'll do a raffle here. As far as other announcements, Manning has supplied a 40% off discount code. So if you're buying a Manning ebook, when you go through the online checkout, you can put JUG13 in there, and it should take 40% off any of their products. DevNexus is coming up. Yes, me and Ted are planning to be there. Maybe Chandra, our speaker, will be there. We'll see. That will be March 4th through the 6th in Atlanta, Georgia, at the Georgia World Congress Center. And if you want more information about that conference, and as I understand it, it's the largest Java conference in North America. It's devnexus.com. Now, the Gateway Software Symposium is coming up soon, too. That's also known as No Fluff, Just Stuff. And so for us, that will be April 4th through the 5th. They'll be at the St. Louis Marriott West, 660 Maryville Center Drive in St. Louis. And we will have early bird pricing available for that conference until February 28th. And if you want the $100 JUG discount code, it's that code right there, JUG1 NFJS25. That'll get you another $100 off if you'd like to attend that conference. So for all the details, just go to nofluffjuststuff.com/ St. Louis. And also, I'm hoping at the March meeting, we will be raffling a ticket to No Fluff, Just Stuff. Jay Zimmerman has been organizing that for many years, and he's been a great sponsor of the St. Louis Java Users Group. Upcoming presentations, I currently have scheduled in All Code Introduction to Domain-Driven Design and Hexagonal Architecture by Jeremy Davis of Red Hat, and that'll be March 13th, back on our normal second Thursday meeting date. So if you want to keep up with our presentation schedule, that's easy to do. Just watch our meetup group. That's meetup.com/gatewayjug for updates to the presentation schedule and location. So as we schedule presentations, you can go ahead and go on Meetup and RSVP for them, so that way you get a reminder. And yes, our presentations are being recorded, and so they're just up at my YouTube channel. You just go to youtube.com/ and yes, that's an @ and my name, Bruce Alspaugh. So if you're interested in giving a presentation or sponsoring the group, once again, just send us an email to the steering committee at javasigsc@googlegroups.com. So enough about me. Let's get to the real reason why you're here. And it's Hands-On Maven 4 with Chandra Gunter, who's an experienced presenter. He's involved with the New York Java SIG and the Garden State Jug. So what I'm going to do is I'm going to click this Stop Presenting button so that Chandra can now take over the screen. Take it away, Chandra.
Cool. Thank you. I'm going to first share my screen, so bear with me real quick. Can everyone hear me fine? Am I audible enough?
I can hear you.
Great, great.
Loud and clear.
All right. So today's topic is Apache Maven 4, and it's a hands-on session on how Apache Maven works. The first thing I'm going to do is turn off my camera so I don't get distracted. So bear with me, and my video is off. So I'm going to go. Can everyone see my screen? Bruce, is my screen visible?
Yes, it looks good.
Great, thank you. So we're going to talk about Apache Maven 4. We're going to start. I just wanted to first give you a few visual cues of what's available, what we're going to go through today. There will be 2 IDE windows that I will navigate through. One of them is Maven 3, and it is marked with a red icon, as you can see. And the other one is Maven 4, which is a more modern version of Maven, which is in green. In addition, everything that I'm presenting today is going to be through the IDE. There's also a PDF file that we could use. Everything's available online. And if you want, I'll give you a minute to actually take a look at where this is present. There's a QR code as well as a URL for anyone who wants to take either a picture or wants to use the QR code. I will also flash this towards the end of our presentation in case anyone needs it. I'll give anyone who wants to take a picture now a minute to do so. Then we can get started. Awesome. All right. So a quick introduction about me. I'm a Java champion. I've been programming with Java for a while. I am an Apache Maven user, heavy user of Apache Maven, and I'm also a contributor to Apache Maven. I write blog series about it. I have it's at my website called cgunter.me. My GitHub presence is located, and so is my Twitter. I'm a Saganist. For those of you who don't know, I follow Carl Sagan. So I'm a Saganist, not a Satanist. Just want to let everyone know that. So just a brief point that I would like to make is a lot of people confuse my last name as Gunter instead of Guntur. I just wanted to differentiate. I'm not an egg hunter. And so I just wanted to let everyone know about that. Awesome. So what are we doing today? We're going to talk about Apache Maven. How many of you in the room, quick poll, I can't visually see you, but if Bruce or anyone could help me out, how many of you are familiar with Apache Maven? Bruce, any responses? I can't see the screen right now.
Right. I don't see any in the Q&A, but I'm going to type into that.
Okay.
Yeah, I use it, so I'm going to type into there. So again, for people who are online, to work around the chat, you actually need to use the Q&A feature. That's the link at the bottom right-hand corner of the screen. There's an icon there uh, with a triangle, a square, and a circle. And if you pick that, you can choose the Q&A option and you can type in there. So if you have any questions, go ahead and type them in and we should be able to see those. All right, take it away.
All right, great. Thank you so much. All right, so the first thing I want to do is talk about the project structure of this project, and we'll go about it in detail as we go along as well. This project is set up such that there is a root project object model or a POM, which is also an aggregator. An aggregator being something that aggregates or runs the Maven commands on multiple child modules. There is a bill of materials child module. Worry not if you don't know what this is. We'll cover this in a bit. There is a child module 1, there's a child module 2, and a child module 3. What child modules essentially are basically different Maven projects that can coexist. And within those child modules, I can have sub-dependencies. In this case, I have a child 31 off of child 3 and a child 32 off of child 3. In addition to those, we also have the child module 32 depend on child 2. That means child 2 acts as a library or a dependency that is used in child 32. Child 2 itself depends on child 1 having been executed. This is the general structure and layout. So I just want to also show that to you in code so you're familiar with the same. So you have the bill of materials POM. You have a child 1, child 2, and child 3, which are parallel to one another. And then you have child 31 and 32, which are children of child 3. Right? That is the general structure and layout. So a quick question around here. I know a lot of people have mentioned that they use Maven, but are you familiar with the concept of bill of materials? Do you have any questions about the layout of the project? If any, now would be a good time to ask. All right, I hear silence, so I'm assuming there are no questions about this, and folk are aware of the structures in Maven. Yeah, if so, I can proceed forward. So the first things first, I could just show you a very quick history of Apache Maven, so you get familiar with it. It's a build management tool, and it's primarily used to build Java projects, but you can also build additional projects on it. It follows convention over configuration patterns. I'm going to skip what build management is. This PDF is available on GitHub for those of you who are interested. Maven follows the principle of least astonishment in that all projects you see that are built with Maven have a standardized structure of sorts and standardized defaults. Maven provides sensible default assumptions that you use in your project, and you're allowed to override those as and when required. Here is an example where you see on the side an image which shows the directory structure that's typical of a Maven project. Can this be changed? Yes, but most people don't change it. The instruction set for Apache Maven is produced through a POM. A POM is an XML excerpt. And what is a POM? Is it a Pomeranian, pomegranate juice, or pom-poms? It's none of those. A POM is essentially a structure that tells you what your project's dependencies are, what are certain plugins, and we'll talk about these in detail later. What are some of the properties of your project? So any kind of inheritance details and profiles and so on and so forth. There's a lot to Apache Maven POMs. We will try to cover as much as we can. And should you have further questions, I'm available on the contacts that I had mentioned earlier. POM is an XML excerpt. I don't expect any of you to read what's written out here, but know that it's an XML excerpt. I'm going to skip the benefits of Apache Maven. I'm not here to sell Apache Maven to you. How does it work? Very quickly. So you have your Java or other language project, and you basically create what's called a project object model. It has a few components like we just covered earlier. You assemble your components. There are dependencies that you list, some plugins which help you execute commands. There are profiles which are generally not recommended, but you are allowed to have profiles. And Maven is made out of build, phases, and life cycles. And we'll cover this in a bit. Maven also provides for an internet Maven repository from which you can get dependencies and plugins from, and also deposit your own libraries and your own plugins too. So it's a bidirectional database of sorts of different artifacts that you can use. Artifacts is a term that's heavily used in the Maven world. Artifacts represent libraries that are jar files or similar package structures which contain content that is either use to execute something or use by your project as a dependency. Apache Maven is an executable. It's something that you download from maven.apache.org. I currently am using two versions of Maven, and I'll show you which versions in a second. You essentially, when you first create a POM, you're assembling what is known as an effective POM. An effective POM is nothing but an overlay of certain sensible defaults Maven provides, and any overrides that you've provided in your POM XML file. In addition to there being an internet Maven repository, Maven also creates what's called a local cache or a local repository on your working device. Maven uses dependencies and plugins as its source for either whatever is used by your project in order to execute commands or whatever is used by your project during its runtime. In addition, there are profiles. Profiles are essentially different constructs that allow you to modify how the build execution works for a given POM file. Lifecycle build phases are something we'll cover as we go along. Whenever you execute Maven, you execute commands through Maven, which then assembles your effective POM, pulls in dependencies either from your local repository cache or from internet if they don't exist on your cache, uses those, executes plugin goals. Those are different terms that we'll introduce as we go along, and builds your artifacts for you. Once these artifacts are built, you can optionally also deposit these artifacts back either to your local cache or to an internet Maven repository if you set up what's known as a distribution management mechanism. So this is the final output of how Apache Maven would work. You have your source code, you have Apache Maven that's executed, assembles your form, executes some commands, and then uses dependencies that are available either locally or on the internet. What is an effective POM? It's essentially just an assembly of all your execution steps, properties, and profiles. It's overlaid, superimposed Maven standard defaults with your overrides on top of it. It is content that Maven uses to execute your project, and there are some exhaustive set of dependencies and plugins used for your specific project, and it's ready for execution by the Maven executable. A lot of people have this confusion about how do I configure Maven? There are different ways in which Maven can be configured. You can have what are the Maven internal defaults. Maven is itself a Java project and provides you with jar files, executable jar files. And in that jar file, there are some internal defaults of some of the content that you see in an effective POM. Maven itself has what is called a base POM, which is, again, the most standard set of components that you get to use. And I'll show you why this is useful later on. Once again, this is located inside the Maven jar. You cannot override it until you go change the source code and rebuild the jar. There is, again, settings that is located inside the Maven that you download and, explode on your computing device. And there is a global settings file. This settings file, avoid changing this. This is usually set at a corporate level or a distribution level. You should avoid modifying the settings XML under the Maven, package structure. In addition to those are the things that are a strict no-no. Avoid changing any of the first three. What you can change is under your home directory, under your user home directory, there is a .m2 directory created. And I use the word directory specifically because I'm aware that there are both Windows, Linux, and Mac, not just both, Windows, Linux, and Mac users. So instead of calling it folders, I'm going to refer to it as a directory. But it's the same concept. Under your user home .m2 directory, which is a hidden directory in both in Unix-like systems, there you can create what is called a settings.xml file, which can override whatever the global settings are or add to them. In addition to those, you can also create what is called a bill of materials POM, which specifies a list of standard dependencies that you could refer to in your project. It's sort of a dictionary that says, hey, whenever I'm using this dependency, use this specific coordinate or version of this dependency for me in my project. So it standardizes the set of dependencies across multiple submodules or child modules of your project. And the best place for you can make changes is in your own project's POM file, the Maven project POM or the pom.xml at the root of your project. All of these are sort of overlaid one on top of the other, where the Maven project POM supersedes everything else and so on, and creates what is called a read-only effective POM for you. This read-only effective POM can obviously not be changed and reflects the content that is merged from all of the above. Any questions on this so far? Any questions on the effective POM or anything not clear about what I just shared? Okay, I don't hear much, so I'm going to just move forward. The next thing that we will talk about is different kinds of POM hierarchies. We've been talking about child POMs for a bit. You can have what is called a parent POM, which is at the root of your project, and you can have additional children of this parent POM, which could again be a parent, and then you can have your own POM that on the project that you work on. In this case, the parent, the project knows the parent, but the parent has no clue about the project itself. So the direction of knowledge is bottom to top. My parent POM has no awareness of the project POM's existence. That is something the parentage hierarchy talks about, right? A parent can aggregate a project in that it can become an aggregation. We'll talk about that in a minute. So hold on to this thought for a minute and we'll come back to it. Aggregation is the second kind of hierarchy we can have in Maven POM files. An aggregator is essentially a reactor of sorts. There's no content that gets inherited, but it groups together child modules that can be executed. Now, bear in mind that although I specified them as 1, 2, 3, and 4, the order is not guaranteed by the way they are written. There is nothing sequential about it. Maven determines the order in which your modules will get executed. It is not you who decides which order they get executed in. Maven decides that based upon the effective POM it creates. So that is something very important, useful to know. Do not assume that since you listed them in a sequential order that they will get executed in the order in which you list them. This is aggregation. An aggregator does not provide any inheritance of content. So the content in the aggregator POM is ignored for most part by the child modules. The aggregator POM knows of its children. The children may not be aware of there being an aggregator. So in the first case, the child knows the parent. In the second, the parent knows the child, but not vice versa. The third kind of hierarchy you have in Maven is a bill of materials POM. A bill of materials POM only provides inheritance. It does not provide anything else. So you list dependencies for either plugins or for dependencies themselves. You list the versions that you're going to use for a given dependency name. And individual projects can actually pull from this bill of materials and use the version specified. A standard example that you may be aware of is Spring Boot. Spring Boot produces a bill of materials. So in your Spring project, whenever you, let's say, use JUnit, you never have to specify the version of JUnit you're using. Spring provides you an opinionated version of the JUnit that you get to use. And you import the bill of materials POM into your project, thereby getting all the dependencies that are opinionated for that particular bill of materials that you get to use. And that is how bill of materials works. So the three hierarchies are parents, where the child is aware of the parent, but the parent is not aware of the child. Aggregation, where the parent is aware of the children, but the children are not aware of the parent. And a bill of materials, which is an altogether different situation. These are the different hierarchies we have. And in our project, we use both parentage and aggregation. We also include a bill of materials to proof of concept, something that Maven 4 introduces. Awesome. So moving forward, Eric,
Hey, we got a question here, sir.
Please.
Oh, okay. Can you go into a little bit about licensing of the various sub-POMs? Is that rolled up or pushed down from bill of material or parentage or aggregation? How does that work?
Can you repeat the what were you?
Particular POM that's Apache licensed. I have a different one that's maybe MIT licensed. Is that something that this helps me manage?
No,
No.
it doesn't. Apache Maven is more about dependencies and plugins, not about the licenses themselves. You have to manage the licenses of the individual dependencies that you're picking up. For instance, you have a project that may use an MIT license dependency or an Apache license dependency or even a commercial commercially licensed products such as Asta or some kind of UML tool that you use, those are managed by you individually. Apache Maven does not have any control over the licenses of the projects that you use. Can I produce reports out of what I do? Yes. Can I control in that saying, hey, you're using a licensed project, you're not allowed to use it? Maybe there is a separate plugin out there that does, but Maven by itself does not have any plugins that do it out of the box.
Because I was wondering if that had anything to do with bill of material.
Oh, no, no. So bill of materials, unfortunately named, is more about a dictionary of sorts. That essentially it's very similar to what a bill of materials in a licensing world is. A bill of materials provides you with a very opinionated stack of dependency and plugin versions that you use in your project. That's about it. So I don't know if any of you are familiar, but the federal government has now created what's called a SBOM, a software bill of materials. The bill of materials follows a similar concept.
Yeah, that's very helpful for finding zero-day exploits. And
Exactly, exactly. So the same concept applies with Maven with a bill of materials.
I had another question. What is the difference between a bill of material form and a parent form? Like,
Great question. A parent POM is about hierarchies. So whatever I have listed in my parent POM get inherited in my child POMs, right? That is a parentage. You have inheritance support in parentage, whereas in a bill of materials POM, there is no inheritance. So the properties I set in a parent POM will be available to the child POM. The properties I set in a bill of materials can be available, but not necessarily are available in a child POM.
Thank you.
Awesome. So these are some examples. I mean, this PDF file exists on GitHub in case you're interested in looking at the details. And now I'm going to switch back to my, I guess, IDE. I'm done with the presentation material part of this. So what are the pain points of using Apache Maven 3? And we are, just note for anyone just recently joining, I have two IDE windows open, one with a Maven 3 red colored icon, and then there's a Maven 4 with a green colored icon. So please be aware of that. So what are the pain points? Let's go through some, I guess, issues a lot of folk face. And Maven 3 has been around for a while. So all of you may be familiar with these. If you're not, we'll go through some of those. Was there a question?
No.
All right, great. All right, so I'm going to just list about 5 pain points that are immediately visible to Apache Maven 3 users. The first one, I think this is very commonly felt, is it is very painful to maintain versions in multi-module projects. And I'm going to walk you through some code. Hopefully, you all can see the screen and the content is visible and clear. If not, let me know and I can increase the font a bit more. All right, so I didn't hear anything back, so I'm just going to proceed. So here's a root POM. This is at the root of my project at Maven 3, and let's go very quick, take a look at where we are in our project structure. We are at the root, and we have a POM XML file, and this POM XML file has a packaging type of POM, which means there is no content produced from it other than an XML file. Nothing else comes out of it. Now, I don't know how many of you are familiar with this dollar variable concept of setting versions for a project, right? Maven 3 had support for this. You were actually able to do a dollar revision, and I'll show you with examples in a bit, live code example, but you were able to modify the version that you are building against by using a dollar revision variable, a boilerplate variable. Now, in order to do this, you actually needed a third-party plugin. And this third-party plugin that you use is if I can scroll down, is CI-friendly flatten Maven plugin. And it flattens, and one of the benefits of getting the flattening is it also provides you versioning capabilities. So that this plugin is what is used in order for you to have a dollar revision variable. And this dollar revision variable, and now I'm going to switch to my IDE, to my command prompt. Once again, in the command prompt, I have 2 command prompt windows, red being Maven 3 and green being Maven 4, right? So I'm first going to do a simple Maven clean install. And I am using an install, although it is not a good command to use most of the times. You want to use a Maven verify command rather than an install. But I intentionally use this so I can show you some code content of what gets produced. So I can pass in a -d revision equals 3.1.0. And this would be a command that would allow me to set a version from the command prompt that I would like to generate. But the first thing I'm going to do is not do this. And I'm going to open up my uh, very tiny font window. And please bear with me. I know you can't read most of the text here, but I'm going to just delete my existing structures inside my .m2 directory repository, none CG utils, right? So I got rid of, let me also get rid of this. So it's empty right now. So there is nothing under the none repository under Maven M2. And M2 is located under my directory structure. It's not visible here. If I do a command shift dot, you'll notice that there is a .m2 directory structure. It's a hidden folder or hidden directory. And under that, I got my repositories. And under my repositories, I have a none, which is what my project is, I guess, set to none.cg utils. That is my group ID, and my artifacts are bomb or other child one, child two, etc. So we have a none structure, and the first thing I'm going to do is try to run this without any variables, any revision variables. And when I run a Maven clean install, and I'm using Apache Maven 396 over here, it produces something, and we'll let it run, let it complete, and you notice that it produced a 3.0.0 snapshot. Where did this come from? And you notice that the bomb has a dollar revision that did not get filled in because the bomb is not created as a part of your child hierarchy. Where did this come from? So let's go back to the root bomb and take a look at a dollar revision property that exists on line number 18. This is how I'm setting the default value for my revision, and that's what gets used. Now, why did I show you this? If I were to go back to my directory structure under none, you now see a CG utils, and it produced all these various artifacts. And one of the artifacts, let's pick up child one. It produced a 3.0.0 snapshot. And the 3.0.0 snapshot is important because I wanted to show you a few things here. It produced a jar file, which is what is the standard output we want. And if you can't read it, don't worry. I'm just going to explain what this is. What's more important is it produces a snapshot.pom file. And this file is very important and critical. So let's just open this real quick. So what did I get? I got an XML file. And this XML file is not just local to you. When you push this content onto a repository, or you pull in any dependency from a repository, let's assume you're using an Apache Commons util library, right? When you pull that in, you don't just pull the jar file, you actually pull these coordinates along with it, which is how you know what your project dependency has further transitives on. What does it depend on? So my project seems to depend on JUnit Jupyter API. But of course, it's a test scope, so I'm not too worried. But if it was a compiler or runtime scope, that particular dependency is also pulled in, and that's called a transitive dependency. That structure or hierarchy of what does my dependency depend on is all listed in a .pom file. And the .pom file is actually very important. Now, if you go to Artifactory or Sonar type repository, Maven repository, you'll find that there is a jar file and there is a POM file there. And that POM file is giving you the dependency information for your dependency. So transitive dependencies are pulled from here. Other important distinctions such as who created this, who are the authors, who are the developers, etc., can all be found in this POM file. In addition, this POM file is not just meant for distribution, it also contains other build information that Maven uses. So your effective POM content actually exists in this POM file. And when you execute Maven, it actually goes through and executes commands that are listed in this .pom file, not what is listed in your pom.xml. Something got generated that can both be distributed as well as used by your execution engine. So that is what a .pom file is. Okay, great. So we did that. Now, this was nice and great. We created a project. And of course, the bomb did not get a revision because the bomb is not inherited from anywhere. So if you notice, although I have a module called bomb, there is no parentage in a bomb. It does not have a parent. So it did not get the $revision variable being set from anywhere else. Now, if I were to go to child one, for example, child one says, I have a parent, my parent is a root, and get the revision from there. Therefore, the child one got a version, whereas the bomb did not. This is a problem. How do we fix this? So now, if I were to come back here on my red screen, which is Maven 3, I again go back and I do an MVN minus D revision equals 3.1.0. Okay? I just created a new version. It's a release version. It's not a snapshot anymore. And I do a clean install. What happens now? And we'll let it run. And we will notice that once it runs, everything got a version number of 3.1.0. How can I verify this? I can go back, and once again, you'll notice that right below the 3.0.0 snapshot, I now have 3.1.0. It produced a 3.1.0 jar, great, and it produced a POM file equivalent for that. It also did the same for my BOM now, because I've now physically passed in a flag which can be set on the BOM. There is no need for hierarchies, and a BOM.POM got created. Any questions on anything I've shared so far? Awesome. All right, great. Now let's come back here. That was problem number one. It required an external plugin for me to actually set this $revision variable. And by the way, this code exists. If you're still using Apache Maven, I feel sorry, but you have a capability to use a $revision using a plugin. Are there other plugins present? Yes. So let's take a quick look. I also have some short links. I'm not going to go through the links for every one of these. But by the way, everything I'm showing you is inside IntelliJ. This presentation is a part of IntelliJ. It's ASCII doc, and all you need is an ASCII doc plugin, and you will be able to render and view the same thing I am. So you have the Flatten Maven plugin from Codehouse and an Outbrain CI-friendly Flatten Maven plugin. The Codehouse plugin has other issues that revolve around interpolation. So a lot of people have switched off from Codehouse and they use CI-friendly Flatten Maven plugin. Right? Both these plugins have a $revision variable that you can use to set the version values. Now, assume you're using a CI/CD build mechanism. You obviously can pass in a $revision as a part of your instruction set, and that version of your product can get built. Right? So there is that feature available, but it's painful because you have to add another plugin to it. The second thing that I would like to share is there is no implicit way to separate build information from consumer information. Now, we've already touched upon this. When we went back to our code, we actually noticed that, let's take child one. You have a .pom file. And this .pom file, as I was sharing earlier, has both your dependency information, that is consumer information that's available on the repository, as well as your build information. Now, why would anyone consuming your dependency or your artifact need the build information at all? This is useless information for anyone consuming this artifact. You need it because you build it, but others don't. And there could be sensitive material here. For example, you have credentials that allow you to connect to a certain distribution mechanism. You have credentials that connect to your SCM. You don't want to expose all those. And they accidentally get exposed because there is a single file called the .pom, and that does not separate between the build information and the consumer information. That is problematic. Once again, are there ways around it? Let's take a quick look. The same thing exists. You can use the Flatten Maven plugin, and the Flatten Maven plugin actually creates two separate POM files, but you use a third party again, right? This is painful. Let's go back to the third pain point. Handling versions of dependencies, dependency sibling modules is painful, and I cannot stress upon this more than that. It is horrible and painful. For anyone who's done this, they know what I'm talking about. Let's take, for example, child 31. Not child 31, child 32 is better. So in child 32, I have a dependency on child 2. I don't know if you remember the graph, but child 32 has a dependency on child 2, right? So going back to child 32, let's take a quick look. I have under dependencies. Child 32 is its parent is child 3. Child 32 is an artifact. Its name is child 32, and one of the dependencies it has is child 2. If you did not use the Flatten Maven plugin and you were to, let us say, cycle to the next version, it is absolutely painful, and you have to hard code values within the version section in order to get there. If you want to use the latest version, you can use a Flatten Maven plugin, set a $revision, and you're all set. And it actually builds the project where it depends on the latest revision of child 2. So child 32 gets built, and then child 2 is built because child 32 is getting built. So they both get built at the same time. You get the latest versions, and everything works fine. If, however, you wanted to depend on an older version of child 2, good luck. You'll actually have to hard code this, right? So it requires a lot of back and forth on how you set your projects. It requires an external plugin. It's painful. The fourth one that is problematic, and this is a serious problem that you only encounter when you start building, is we are developers, which means we are lazy. we use default versions of plugins. And I'll show you a very quick example, right? In my let us say POM1, I have not listed any kind of plugins for my compiler. What version of my Maven compiler plugin am I using? Can anyone hazard a guess as to which version of the Maven compiler plugin is being used to build the Java code here?
You'd have to look at the parent POM.
Okay, let's take a look at the parent POM. All right. Is this good enough?
No, I meant the parent POM of the plugin, I guess.
Yeah, so let's assume I set a plugin management, and in my plugin management, I set the version to use 3.13.0, right? I'm assuming this is the version that gets used. So let's verify. Let's quickly verify what's happening. Let's go back here and take a look at the compiler plugin being used. So if you notice, you have the compiler, and it is using what version? 3.13.0, and that was the version we set. Now, we had the good discipline to do that, right? So let's assume I become myself an indisciplined Java developer, or indisciplined build meister, right? And I don't set this. Now, can anyone guess what will happen? What version will get used? All right, feel free. It's an interactive session. I want answers. They could be wrong.
Latest?
Two.
All right, someone said latest. Someone said, I couldn't hear the other person. Sorry. Two? Okay. All right. I don't want to keep you in suspense. So let's just run this real quick, right? Let's run the same command we ran earlier. We don't want to do anything magical. So we'll just rerun the same command. And let's see what happens. All right. So we built products. It was successfully built. But let's take a look at what got run here. So where is my compiler? Guess what happened? We used a compiler version 3.11.0. But how? Why? So it goes back to the earlier, I guess, content that I was sharing is, remember how there are some sensible defaults that are set in the Maven jar? And one of the sensible defaults set in the Maven jar is the default version of compiler for that specific version of Apache Maven is what is getting used. Most of the time, serendipity, this works. But sometimes this will cause you issues because you're using a wrong version. That's when your aha moment strikes you. And that's when you have to go back and set your, I guess, compiler version in your plugin management. What if there was a warning here? What if someone told me, hey, you're using a default, just be careful. Apache Maven 3 did not have that. We'll take a look at Apache Maven 4 in a bit, but I just wanted to highlight some of the pain points that exist with Apache Maven 3. And these may look synthetic and small, but these are big changes that happen on the internals to provide us these features. The fifth pain point, and the last one I'm going to cover here, is there is no explicit bill of materials POM packaging in Maven 3. And case in point, here's my bill of materials POM. It says BOM over here. What is its packaging type? Its packaging type is a POM file. Why is that the case? Why is it a POM, not a BOM? Why can't I have it as a bill of materials? Why does it have to be called a POM file? There was no distinction, right? And so even if you go to the Spring Boot, right? Spring Boot, the latest version, you'll notice that it's a POM packaging and not a BOM. Apache Maven 4 is not yet out. It's release candidate. Hopefully it'll be out very soon. And the moment it is out, I'm assuming things will change and people will start using the BOM packaging. So those were the pain points of Apache Maven 3. Now let's take a look at Apache Maven 4. I'm going to switch my ID from the Maven 3 to the Maven 4. And here I am on Maven 4. Looks very similar. The project structure is almost the same. You still have your bill of materials, child 1, child 2, child 3, 31, and 32. So far, so good. The project structure still remains exactly the same. Nothing changed. You have your root. You have your 4 children below the root. And child 3 has 2 children. The dependency structures stay the same. So nothing changed. So what are some of the changes that happened? Let's take a quick look. Let's go back to the pain points and then address them in code. The first one, it is painful to maintain versions of multi-module projects in Maven 3, going back to Maven 4. How does this change? So here is my root POM. And in my root POM, I have the $revision variable. Okay. But there is no need for me to use any third-party plugins. This is built into Maven 4. Now, of course, you'll notice that there is an error. You'll notice that the module version number shows incorrectly. There's a problem with the IDE. It has nothing to do with Maven itself. So please be aware when you see content in red or an error message, it's because my IDE has still not caught up to Maven 4, and it won't until Maven becomes a stable release. Maven 4 becomes a stable release. One of the few changes you will notice is the model version has changed from 4.0.0 to 4.1.0, as has the namespace from 4.0.0 to 4.1, and the schema location as well has changed to 4.1.0. Okay, so these are some of the significant changes. More importantly, you don't need a plugin. There is no Maven, flattened Maven plugin required for you to use a $revision in Maven 4. That's one of the new positives in Maven 4. What are some of the other pain points we encountered? There is no implicit way to separate build information from consumer information. Now here's where I'm going to start demoing Maven 4. So let's switch windows. As you can see, I don't know why I'm on beta 3. I should be on RC2, but beta 3 should work as well. Let me quickly see if I have RC2 and I can change it over. Give me a second. Tools. I believe I have Maven 4 RC2. I could change that. If we have time towards the end, I will make a change and show you that works as well. But I'm on beta 3, which is one version older than what the RC2 is. Awesome. So if I were to now run mvn clean install, okay. Once again, I'm just going to start with vanilla outputs. Let's take a quick look at our Maven 4 structure. I have the $revision variable. I have a BOM file with the $revision variable. I have my child, which has no version listed at all, and we'll see how it works. So I'm going to run the Maven clean install. And when I run this command, it does a few things. So let's take a quick look at what the differences are. We know the bill of materials is going to show the $revision because it's not in the hierarchy, the same thing as Maven 3. That is natural, and there's nothing we can do to change it or should do to change it. But what happened on my Maven 2 repository structure? So let's take a quick look. So I go back to my repository, and under none, CG utils. I now still have the same structures here. So let's take a look at child 1. Here's my previous runs. There is a 3.0.0 snapshot and a 3.1.0. These were some things we've seen before. And now there is a 4.0.0 snapshot. Let's take a quick look at the content here. I have my jar file, which is almost the same as the jar file produced in the past, but now I have two POM files. There is a .pom file and a build POM file. And the build POM file is something I care about because I am building the project. And the POM file is what a consumer of the POM cares about because they care about the dependency or the artifact. They don't care about the build information. So needless to say, when you open this file, there should be no build information in it. What it has is the model, group, artifact, version, name, dependencies, and that's about it. There should be no build information here, right? Because the build information and other sensitive information, such as your SCM details, distribution management details, are unwarranted and not needed by the consumers of your POM. They just need this information, and they get exactly that, the transitives and the dependency management for your given artifact. So what then is the build POM file? The build POM file is a separation from the consumer POM and used by you as the builder of the project, and it contains build information for you. It contains the properties you use to build your project. It contains any plugin structures that you use for your project. It contains, SCM, distribution management, repository information, plugin repository information, etc., which the end consumers have no business knowing about. All that exists in the build POM. Right, so there is a clear separation between the POMs that are used by the consumer, known as the consumer POM, and the POMs that are used by you as the build meister, also known as the build POM. There's a clear separation in Maven 4.
I can put my my password for opening my signed certificate for my code in there.
Right. So there are best practices, and there are what you can and cannot do technically. The question is great.
That in Eclipse, where I was writing a plugin, but it was a signed plugin because I want to make sure that I'm the one that wrote the code. But I didn't want that in my POM because then everyone else would see the password into my certificate.
Correct.
So I had to create this stupid workaround with Bash that was horrible.
Right. So there are different ways around it. And one of the best recommended practices is for you to put such information either in a .m2 file, a settings XML file, which exists at your .m2, or you have what is called the Maven config, which is located under the .mvn directory of your project. Now, even in the Maven config, you don't put actual values. You put references to environment variables that you can pull in during your build process, right? And that is the best practice that you use, where your code, when it is pushed to, let us say, a version control system that doesn't sit on your computing device, you don't share sensitive information, right? So you can use secrets management. You can actually use Maven config. You can actually use a settings XML file that's local to your device. All those are different options you have. Can I still put my information on the POM? Yes, but you should not. Does that answer your question?
Yeah, no, it's good.
Right. Awesome.
So that was possible in 3 then. That's not new to 4.
Right. So with 3, if you use a flattened Maven plugin, you still have the capability to do that, but your source code will still get pushed to an external location. So it's not a question about 3 or 4. It's more a question about what are different practices available. Maven 3 also supports a .mvn Maven config location. Maven 3 also supports a settings.xml file where you can put content, right? It is just a best practice on how you use it.
Okay, thank you.
Great, awesome. But great question, thank you. All right, so going back, we saw the pain point build versus consumer separation, which exists in Maven 4 as out of the box without the use of any plugins. Going back to Maven 3, the third pain point that we had, handling versions of dependency sibling modules is a chore in Maven 3. We saw that we actually had to use a dollar revision. The better way to do it with Maven 4 is right here. So I have my child 32. Let's go to my child 32 because that's what we were looking at. So I have my parent POM. I don't specify the version. Notice there is no version of my parent. I have my child. I have my dependency, and I don't have a version because it's automatically generated by Maven for me, right? Although I don't put a version here, it automatically fills it in when I do my build. I'm going to show you the example. I'm going to show you the .pom file that gets generated, and you will see that it has a version number in it. Okay. Now, this is a synthetic change, but it also is very impactful. Version was a required attribute of dependency in the past. Version is no longer required, and it is intelligent enough to figure out when a version can be supplied or when a version should be required. Was there a question? Sorry. Bruce, can you let me know if there was a question? I heard someone say something. All right. I'm going to assume that there was no question, but let's quickly take a look at the child 32 POM and notice what the version it set when we ran the build. So going back to my M2, under my repository, none CG utils, we go to child 32. And we go to the 4.0.0 snapshot. Let's take a quick look at the POM file it built for us. So this is the consumer POM. The one without any suffix is a consumer POM. And if I were to open this POM, let's see what its values are. In here, I should have child 2 listed somewhere. So let's take a quick look at the dependencies we have. So if you notice, child 2 has an automatic dependency of 4.00 snapshot. It was added for you because Maven figured out that the version, if you're not supplying it, has to be something that you use already to build the remaining part of the project. Right. So the same thing now, we'll repeat the same steps. In the past, what did we build? We just used a Maven clean install. And now we're going to alter this command to actually run with a revision -d revision equal to 4.1.0. And I run this. Awesome. So small change. What did we do? We actually just provided a version number. Therefore, the BOM also got a revision, 4.1.0, and all the children were built. I don't want to go back to the code there because it looked very standard to what it looked in 0.0 snapshot. But let us take a quick look at what else it did. The first, you notice that there is a lot more verbosity in your build output. And the second, you actually now get a warning. What is this warning? It says you're using a Maven install plugin, but you've not provided a version. And with CI systems, you can actually fail builds that throw a warning. So you now have a capability of knowing that you're making a mistake, and you can actually stop the build when you don't lock your versions. Why is this useful? Let's take a quick look. If I were to go back to my root POM, and as we did in the past, I am going to comment out my compiler plugin. Remember when we commented it out in the previous version, it set it to 3.11.0. Let's see what happens now. So I'm going to run the same command now. And instead of 4.1.0, let's say I'm going to call it 4.2.0, because why not? All right. You'll already notice that it's throwing some warnings. And if you're used to color output in Maven, which is better on IDEs than it is in command prompt, you will see a warning that says your compiler plugin does not have a version, right? And when it does this, it's actually giving you information that allows you to break the build. However, also with Maven 4, the compiler has moved to the latest version. So you are getting 3.13.0. That can become stale too, just be aware. Right? So Maven has now produced warnings on the plugins that you don't set properly. So it's giving you warnings, and in case of stricter build systems, you can fail a build based upon a warning. Right? So that's a new modern change that prevents laziness from making mistakes or causing us grief down the line. That's one thing Maven 4 has introduced. The last one is quite simple. There was no explicit bill of materials POM support in Maven 3. Go back to Maven 4. You notice that the BOM has a BOM packaging, not a POM packaging. That's a superficial change for most developers, but it's very serious a change for, I guess, libraries or people who produce bill of materials. There is a clear distinction between a POM and a BOM now, right? That's a major change. So just to summarize the outcomes, what did Maven 4 do? Maven 4 version support is much more improved. Now it's possible for you to support dollar revision variables right out of the box. You don't have to do much. You have clear separation between the build POM and a consumer POM without the use of any plugins to do the same. When you have implicit versions for dependency or sibling modules, they're easy to control. You don't even pass the version. It's an optional attribute now. Maven issues warnings when plugin versions are not included when you're selecting default versions, and you can actually block builds based upon warnings. And Maven introduces a BOM packaging option, which is awesome. Any questions on anything I covered so far?
Yeah, I just had a simple question. When will Maven 4 be officially released?
That is an
And
excellent
out of that, and also, what minimum version of Java is required for Maven 4?
excellent
Can
question.
we
Thank
still
you.
use Java 8?
Yeah, so you cannot. Maven 4 onwards will support Java 17 as a minimum version of Java. That's number one. Maven 4 is on its release candidate 2 right now, which means it is very close to being a full release. I would assume with the cadence that Maven is going for, I'm assuming 3 to 6 months is when Maven 4 will come out. But you are free to start using the release candidate. It has already been declared stable enough. So not much will change from now. Don't know if I answered both your questions.
Okay.
Awesome.
I had a few more.
Please.
Now this was several years ago. I don't know if you remember, but in Java 9, Project Jigsaw
Yes.
was released so
Yes.
that you could have
Modules.
Java modules.
JPMS. Correct.
Yes, JPMS.
Yes.
I tried building a multiple Java module project as opposed to a multiple Maven module project. And I ran into a number of problems. It is possible with Java 9 and up to create a multiple Java module project, but only call the compiler one time.
Yep.
And it compiles all of the modules.
Yes.
But Maven, in its default directory format, arranges the modules differently than what the Java compiler expects. It needs a different directory layout. When you do one single call to the compiler, you got to lay it out the way the compiler wants it.
Correct.
So I ran into that problem. And also there's a problem with the life cycles. The problem I ran into there is, I don't have much control over when Maven decides it's going to build this module versus that module. It decides.
Correct.
And if you want to generate consolidated Java doc that spans all of those modules so that it's searchable across modules like that, you've got to do it so it's one call to the Java doc command. And so I again ran into this problem of life cycles and directory layout.
Fair.
It looks like maybe you have a solution for me.
I haven't attempted a solution since the Java doc portion, right?
Okay.
There is a project I have on GitHub, not the one I'm sharing now, but another project where I do a Maven multi-module. And by multi-module, it's a multi-Maven module, multi-IntelliJ module, and multi-JPMS module project, right? We could experiment with adding the Java doc on it together and seeing how that can work. But essentially, it's an aggregator. So it runs them. Of course, the order is not non-deterministic by you. It is Maven who decides it. Yes, that's a challenge, but it is still possible to run the same command. I'm going to show you a few more commands in 2 minutes or so, which may help you see how Maven 4 may do this better. So
okay. Where is this project so I can find it?
So if you go to my GitHub repository, C Gunter, which is the same link as I was posting earlier, C-Gunter. I have a project called Maven-IntelliJ. I'll share the link. If you give me your contact information, I can send you the links to both these projects later on. But yeah, my intention was to create a multi-module that is all a Maven module, an IntelliJ module, and a Java module hierarchy, right? And how do they work together? The only thing I don't have in this yet is a Java doc, but we can definitely address that together. It's quite simple a change to add that. And if you want to contribute to this, please do let me know. I can open this project up for contributions.
Okay. Yeah, great. I may follow up with you later on that.
Excellent.
Also, one of the other features that came out about that time was the concept of a multi-release jar file.
Yes.
How do I build one of those?
Yeah, so MR jars or multi-release jars are where you, for the rest of the folk who are not aware of it, is when you can produce multiple jar files or a jar file that supports multiple runtime versions of Java. Why is this important? There were some changes made in Java 8 onwards with invoke dynamic, lambdas, closures, anything related to JSR 292, which led to, I guess, some binary differences. And with a multi-release jar file, you can produce a jar that's compatible with older versions of Java and one that is compatible with newer versions of Java. And is that supported through Maven? Yes, it is. You just have to use tool chains for that. And there are ways in which you can set up where you can produce multiple jars, either using profiles or tool chains or a combination thereof. So once again,
do you have an example project?
Yes, funnily enough, I do have an example of that, but it is antiquated. So bear with me, but I can share with you some examples of how to do multi-release jar files. I have a ton of repositories. I just have to find it, but I know I have one of those repositories out here as well. It's been a while since I've done it, but it does exist. So we will take a look. Yeah, please do contact me afterwards and I'll share with you. I think it's this one, but I'll share with you how to do that. Excellent.
Okay, great. Thank you. Any other questions?
Yes, I've got a question. At work, we're rather conservative. We're still using Maven. It's been used it for a long time. And to get to be able to change properties, to be able to change the versions across projects and so forth, we use a properties element inside project in Maven 3. Right. Instead of having to, pull in a dependency to do the whole thing. And that's the way we do it. So I just want to pass that along.
Yeah, so the pain point with using properties is when you set the properties, you cannot actually without the introduction of a dollar variable, or without the provision of hierarchies where there is inheritance, you cannot move things forward. So can it be done? A poor man's version, yes, you can use a property and set it. It does work. What if you're using a CI? What if your property needs to be set from outside? How do you push it? How do you push it if you have filtered tokens? Those are some of the challenges because of which the whole flatten Maven plugin was created. There was a pain point and it was addressed, right? So the bottom of the pile, you have a property that you use. And then when people found out that's not enough, a flatten Maven plugin was created, but it requires an additional plugin. And then you get frustrated because you have to now maintain this plugin, which is why Maven 4 was introduced, where you get rid of all these concepts. Don't know if I answered your question.
Thank you, you did. I just wondered why that wasn't good enough. Thank you.
Awesome. All right, great. So I do have a few more slides, so bear with me. And please do let me know if this is material that you're finding interesting or not. If you're not, I can change and go back to the deck. But some of the other changes that were made between Apache Maven 3 and 4, and this is useful because this will help address a lot of the questions that are now coming up. Let's take, for example, I have an aggregator being a POM that just builds other projects, sub-projects. The aggregator knows about the sub-projects. The sub-projects don't know about the aggregator. So I have an aggregator, and this aggregator has, let us say, 4 child POMs. Let's go back to the project structure. I don't know if you recollect, but my root is an aggregator over here because it by itself has no code. The only thing the aggregator does is say, when I run a command against the aggregator, it dispatches the command to the rest of the children. That's all the job of an aggregator is. So if I were to look at my root POM here, let me close the assets. At my root POM, all I have in my root POM is a set of modules, which is BOM, child 1, child 2, and child 3. It is an aggregator because although my POM exists, my child POM has no information about this POM existing. So it's an aggregator of sorts, right? So that's your aggregator. And when you use an aggregator, all I want to do in my project structure is I want to build child 3, child 3.1, and child 3.2, nothing else. I don't want to build child 1. I don't want to build child 2. How is this possible, right? So let's take a quick look at what Maven 3 and Maven 4 do. In Maven 3, these are the different commands or magic. Some may work, some may not, but this is the way in which you do it. You say Maven clean, compile, and I'm just compiling, right? I'm just building. I'm not installing. I'm not doing anything else. Just a simple compile. And I'm passing in a project list, PL. And the project list I pass is child 3. And I pass in a flag, which I have to remember, known as AMD, which also stands for also make dependents. So what does it do? It builds child 3, builds child 3.1, and child 3.2, right? Because that's what the project list says. So either a dash AMD or a dash dash also make dependents, or worst case, I actually fully pass in all the list of children that I want to build. So I pass in child 3, child 3/31, child 3/32. Painful, not very obvious. What do I do with Maven 4? I simply say Maven clean compile project list child 3, and it builds the dependents for you, which is how versions get carried over, which is why I don't need to specify versions anymore. It's an architectural or a paradigm change in Maven 4 from Maven 3. That's change 1, right? So it makes it simpler for you to build substructures and ensure that all the dependents of that substructure also get built. Any questions about this? All right, great. The next one we're going to look at is how can I build an aggregator but not its child modules? So I just want to build child 3. I don't want to build child 3.1 or child 3.2, right? I just want this particular component built and nothing below it. Because in the previous example we saw, when I were to pass in the project list, it builds everything below my hierarchy. What if I did not want that? What if I only wanted to build child 3? The Maven 3 command is unobvious because it does exactly what Maven 4 does for building the child modules. This was unobvious because it felt more like, hey, when I'm building child 3, my expectation is that the dependents also get built. And that was this does not satisfy the principle of least astonishment, which is why in Maven 4 you actually have to specify and deliberately state your intention that you don't want the children built. If you don't specify this, the children will get built. So only in situations where you absolutely don't want the children built, you will pass in a flag. So the flag has been reversed, which is much more, I guess, logical and cohesive when you think about it. When I run a project list for that matter, it doesn't even say project, it says project list of child 3, you expect the children to be built as well. But in this case, Maven 4 has made it very clear that when you specify the project list and say no, it actually says don't go digging further down and build the children. Right? So it's an architectural or paradigm shift again. The third change, I want to build the module plus the dependencies of the module, not just the dependencies. I want to build the dependencies that are outside of the current scope, right? So in this case, I want to build child 32. That's number one. And when I build child 32, I need to build child 3. And when I build child 3, I also know that child 32 depends on child 2. So I want that built. Child 2 depends on child 1. I need that built. And because I'm building all these, the root will get built. It was not possible in Maven 3 at all. It's still not possible to do this in Maven 3. So that's one of the challenges that I was talking to the earlier gentleman. When you have Java modules, this is the kind of challenge you'll face because Java modules follow this kind of structure. And it was never possible for you to build a part of your hierarchy and nothing else. In this case, I wanted to skip child 31. I wanted to skip the POM. It was not possible. With Maven 4, you're going to specify, you're going to navigate to child 32. That's number one. That's a small price to pay. But once you navigate to child 32 and you Maven compile and you pass in a -am, which stands for also make. It makes all the dependencies of your project for you. So it makes child 32, which means it has to make child 3 and child 2. And child 2 requires child 1. And all of these require the root. So those get built. Let's take a quick look at running this command on our command line, right? So let's go back and verify that this works. Let's not just talk about it. So I'm first going to PD to this. So let's see what we're doing. I'm going to copy paste the whole command and run it, right? And I'm going to pass in a -d. I don't even need the version number, but I'm just going to specify it. Boom, 430, root, child 1, child 2, child 3, and child 32, version 430 got built. Did I build child 31? Did I build the bomb? Absolutely not. So Maven 4 supports this. There is no equivalent in Maven 3, so don't even know what to show you on the red screen. Awesome. That was another change. Is there a question? Sorry. Sorry, I didn't hear a question, so I'm going to move forward. The last change I wanted to share with you, I want to build a module plus the dependents of this module outside of the current scope. So when I build child 1, what depends on child 1? Child 2 depends on child 1. What depends on child 2? Child 32 depends on child 2. So when I build child 1, I want these two also built. So I'm looking at an impact of whatever change I make, what is the impact on people who depend on me? This is a very common use case. Think about it. You build a library and you're looking at what does my change to the library, how does it impact the other projects that depend on this library, right? Guess what? In Maven 3, it was not possible to even do this. You could not do it, right? With Maven 4, the command is you navigate to the child 1, and then you compile and make dependencies. So when I make the dependencies, sensibly enough, it figures out, also make dependent, sorry, it figures out what depends on child 1 and builds those as well for you. It knows that child 1 has a dependency on child 2 has a dependency on child 1, so child 2 needs to get built. Then it looks at the dependence of child 2 and finds out child 32 depends on child 2, so it builds child 32 as well. So when you make a breaking change, you get instant feedback in Maven 4 that did not exist with Maven 3. Right? This is a massive change, guys. Think about it. Now I can actually test my changes without having to go determine which other parts of my project break because of a change I'm making in some more senior component. Right? And once again, let's put it to the test. The proof is in the pudding. So let's go back here. I'm back to my Maven 3 and I need to navigate upward again. So I'm back in Maven 4 and I'm going to cd child 1. And here I am. And let's see, I'm going to run the Maven compile -amd command. And just so we are sure that we're building the right one, I am going to pass in a revision 4.4.0. Now, I mean, there is no equivalent command on Maven 3 I can show you, but this is what happened. Because I built child 1, my impact analysis, child 2 needed to get built, and it looked good. And then child 32, which depends on child 2, needed to get built, and it looked good. This was not possible in Maven 3. So there are some amazing new features added in Maven 4, which allow you to actually improve the quality of your project, improve readability, change the defaults to be sensitive, remove the principle of least astonishment issues that Maven 3 had, and which is why Maven 4 is awesome. So that in effect is what I wanted to share with you today as a presentation. Thank you so much for your time. I'm going to stop sharing and turn back my camera on.
Yeah, I had a question just to follow up. Does Maven 4 help us in the area of what I would call dependency hell? So I'll give an example of that. So suppose I'm writing a project and it uses third-party library A and it uses third-party library B. But the problem is third-party library A and third-party library B depend on different versions of the same library C. And if you try to have two different versions of library C on there, you're going to run into problems. One could shadow the other.
Okay, so I'm going to go back to
cause all
sharing my
kinds of
screen.
stuff. So
I'm
how
gonna
do
go
you
back.
track that down? What can you do?
Okay, let me go back to sharing my screen because I do have this
Okay.
as one of my slides. Bear with me as I just open this file up. And for folk who are still on, I'm going back to sharing my screen, so bear with me. Okay, so I'm trying to navigate to the slide I wanted to show. And let me just share my screen while I do this. I still have the ability to share my screen, right? Yeah, looks like it. Okay, so I'm going to turn my camera off so I can actually share what I'm showing you here. And let's go quickly to the appendix. This deck is present in the GitHub repo that I shared earlier. But let's go quickly take a look at the dependency management for. Did I miss that slide completely? Oh, sorry. Signed the wrong one. Okay. Give me a second. I'm just going to navigate to the dependencies. I wanted to show you how the dependencies look like. Okay, so this is the dependency hell that was being talked about, where you have dependencies, sub-dependencies, and there could be the same level dependency from multiple, I guess, transitives. How do you manage this? So this is the dependency graph that both 3 and 4 use. I mean, nothing has changed, but essentially what happens is you have the dependency graph where dependency dx version 1 is being used by one dependency, dependency dx version 2 is being used by another dependency, version 3 is being brought in by another, and 1.5 is brought in by the fourth. Which one do you think will get used in this case? Anybody?
I have no idea.
Awesome. Well, Maven definitely has an idea, and that is the most important thing to understand. The first thing to do is always create your dependency tree. And if you use I guess any professional IDE such as IntelliJ Ultimate or similar, you can actually create a dependency graph for every POM XML file, and I'll show that to you in a minute. But meanwhile, just the blues, right? All 4 blues are exactly the same dependency with different versions. So the way Maven works is it builds a graph. Like any other good tool in this world, a graph gets built. In this case, a dependency graph. And the dependency graph is traversed as with the path of least resistance. So the first step, does this dependency exist at this level? Does dx exist at this level? No. So it doesn't get picked. Does dx exist at this level? It does. Where is it first encountered? Here. This gets picked. Will anything else further be looked at? No. So what version of this dependency will be picked up? Version 1.2.0. Immediate question folk ask, but there is a 1.5. Immediate answer I give you, what was the first one it found in its path? And Maven does not understand versions because, surprise, surprise, versions are not numbers. They are strings. And how are strings compared? Strings are compared based upon where they first show up. If they're the same size, this one gets picked up first. So if you really wanted version 1.5.0 to be picked up, or say 1.3.0 to be picked up, your options include DX version 1.3.0 right at this level, first level, or specify the dependency higher up. Those are the only two ways you can guarantee which version goes. Specifying the version up could bring problems later on. It's a maintenance hassle. So if you ever wanted to enforce a dependency version that you want to use, specify it on your POM XML directly and it'll get picked up. Or use a dependency management and it'll get picked up. Okay, so that is standard between Maven 3 and Maven 4. And that's how version dependencies get picked up. Don't know if I answered your question.
Yes, that helps a lot. Now, how do you generate this dependency graph so I can see what Maven's doing?
Awesome. So let's go quickly take a look at that. I mean, you have to use IntelliJ Ultimate for this, right? I use IntelliJ Ultimate Edition, right? And it's licensed to me. I pay for this. But if you were to go to, let's say, a POM file, right? Click on the POM file and diagrams, show diagram. It actually lists everything that you have in your POM in a directory structure, and you can start using it. As simple as that, you can actually set up, let's go, maybe this one has more diagrams, show diagram. No, it doesn't. For some reason, it's not showing me everything Maven has. Give me a second. Right. Mine's probably buggy at this time. When I do all, it should actually show me child 31. It's not showing me that, but something, I may be on an older version of IntelliJ right now. I need to fix that. But yes, there is a way in which you can actually see your Maven. Oh, you can see the effective POM if nothing else. Give me a second. Did I not? There's something buggy going on my IntelliJ. But yes, there are two ways in which you can do it. One of them is right-click, diagrams, show diagram, or Maven, show effective POM, both of which will show you your dependency structures. I probably need to restart my ID or invalidate my caches. So bear with me. Sorry, I don't know why it's not showing me either right now. But yeah, those are the ways in which you can do that.
Thank you. So are there any other questions?
And in the past, I used Maven on dependency column tree, that where you generate the whole tree structures.
Yeah. So yeah, so the Maven dependency tree is nice, but it is not complete. Right. So that's something you have to be aware of. It doesn't do a full transitive in-depth analysis. If you really wanted a full intransitive in-depth analysis, you have to do a Maven dependency colon tree minus uppercase X, right? That's extreme verbose. And be aware that it'll produce about a meg of data. So you want to redirect that output to a file and then read through it. That's when you'll actually come to know what's going on with your POM file. Is Maven dependency tree good? It's great for initial check. But if you wanted a more verbose output and I can run it, it actually will produce almost like 500 kilobytes to a meg worth of content that you want to redirect and then go through. Don't know if that is something you've tried. If not, please do check it out.
Okay, great. Well, if there's no more questions, then thank you very much. Usually we have a round of applause here for our presenter at this time. And I'm going to go ahead and stop the recording here.
Did Edward raise his hand? Was there a question? Sorry, I didn't know.
I was trying to clap. Thank you very much.
Thank you.